Hello and welcome to the OCR Further Maths videos for Pure Core. This is Hyperbolic Functions 2, Inverse Hyperbolic Functions.
Okay, so first of all we're going to look at finding the inverse of sin x. Now you may remember from work that you've done in A-level maths that the inverse of a function can be found by a reflection in the line y equals x. So here we have the graph of y equals sin x and the line y equals x. And if we draw the reflection there, we can see we have the inverse sin, which is y equals r sin x. Now, because sin is a one-to-one function, we can straight find the inverse. Later on, we'll see that it's slightly different when we look at cosh x. So, the inverse function of sin can be written in either of these two ways, and you need to be familiar with both, like when you're looking at trigonometric functions, and you can write the inverse as sine to the minus 1x or arc sine x. So we can see here from the graph that x as a function of y is a reflection of y as a function of x in that line y equals x. And that means that we can have an algebraic method to find an expression for r sin x, which we're going to now look at. So here we go. We're going to start with y equals r sin x, which means that sin y must equal x. Okay, so that means we know from the definitions that you've seen in previous videos, x is a half e to the y minus e to the minus y. What we're going to do now is we're going to go through this and we're going to write this so that y is the subject of this formula. Okay, so we're going to write this as 2x equals e to the y minus 1 over e to the y. So 2x e to the y equals e to 2y minus 1. I'm going to bring everything over to one side. And now you can see we have a quadratic in e to the y. We're going to complete the square. E to the y minus x, so it's exactly the same. Here the coefficient is 2x, so half of that is x squared minus x squared minus 1 equals 0. And now if we rearrange, and then e to the y minus x equals plus or minus the square root of x squared plus 1. So e to the y is x plus or minus the square root of x squared plus 1. Remember, what we want is this y to be the subject of the formula, not e to the y. So we're going to need to take the natural log of both sides. Now, in this particular case, this would not be defined if we had a minus here, because that would be log of a negative. So it's r sin is just defined for positive here. Okay, so there's a slightly neater version. You can see that it isn't defined for the other root. Okay, now you can look here, you can find the inverse of cosh x in a very similar way. However, you need to note that because cosh x is not a one-to-one function, we need to restrict the domain in order to find an inverse. You can only find inverse functions for one-to-one functions. So that means that what you end up with is for r cosh, you've got log of x plus the square root of x squared minus 1, just one value. However, if you're solving the problem cosh of x equals k when k is greater than 1, you can see that for each of those there would actually be two solutions here on the graph. And it's really important that you remember the difference between the inverse function and solving an equation. So in a similar way, you can find the inverse function of tanh. And you can see here all three of our inverse hyperbolic functions. Note the difference in validity for each one. Shine is valid for all x. Inverse cosh is only valid for x greater than or equal to 1. And for tanh, it is between -1 and 1. Okay, so we're going to have a look at a quick example now. We're going to solve 2 cosh x minus 6 equals 1. So first of all, just going to rearrange this. So we have cosh x equals 3. So now if we do the inverse on both sides, we have x equals cosh to the -1 of 3. And so here we're just going to use the definition. That is that cosh -1 of x is the log of x plus the square root of x squared minus 1. Okay, so in this particular case we can see that x is 3. So we're going to have x equals ln 3 plus square root of 9 minus 1, which is ln of 3 plus root 8. Now, if you remember in the previous slide, we talked about the fact that this would actually have 2 solutions on the graph. So we need to find the other solution, which would be ln of 3 minus root 8. So we can see these are our 2 solutions to this equation. Okay, the next video in this series will be 2.2, differentiating inverse hyperbolic functions.